Good evening. My name is Dr. Rambabu. I am working as Assistant Professor in the Department of Electronics and Communication Engineering. I am from B.V. Raj Institute of Technology. Today, I am dealing with the topic called Architecture of 8086 Microprocessor and Register Organization of 8086 Microprocessor. This is the part of microprocessors and microcontrollers subject. Here, before we are going to talk about architecture and register organization of 8086 microprocessor, first let's see what are the main features of the 8086 microprocessor. And before we are talking about the features of 8086 microprocessor, first we have to know what are the main learning objectives of this particular topic. Here, starting with this course, everyone must know the main objective of that particular course. At the same time, we have to know the learning objectives of the topic also. Coming to this topic, the students will be able to understand the basic features of the 8086 microprocessor. Next, students will be able to understand the internal functional block diagram of 8086 microprocessor. Students will be able to understand the pipelining concept in 8086 microprocessor. And the last one is the student will be able to understand the function of various registers in 8086 microprocessor. These are all the main objectives of this particular topic. And this is the real-time 8086 microprocessor. And top of this particular IC that is mentioned as 8086 microprocessor. This is invented by the company called Intel in the year of 1978. Coming to the features of 8086 microprocessor, the 8086 microprocessor, mainly this is a 16-bit microprocessor. Actually, this particular feature depends on the ALU operations, the internal working registers, and another one is the data bus size. Mainly, 8086 microprocessor contains the 16-bit data bus. That means totally this contains the data lines are D0 to D15. That means totally this having the 16 data lines from D0, D1, D2 till D15. And coming to the address size of the 8086 microprocessor, totally this contains the 20-bit address bus, and it can support up to 64K IO ports. And totally 8086 microprocessor is having the 14 registers. Each register size is 16-bit. And in this address and data bus, some data lines are multiplexed. Those lines are AD0 to AD15 and A16 to A19. Those lines are multiplexed with some other status signals. And the duty cycle of 8086 microprocessor is 33%. Here we can able to operate our 8086 microprocessor in two different modes. One mode is minimum and another mode is maximum. And another best feature of this 8086 microprocessor is comparatively to our 8085 microprocessor, here it is having the 6-byte instruction queue to speed up the process. And the operating voltage of 8086 microprocessor is plus 5 volts. Totally 8086 microprocessor, here it is contains the 40 pins. 40 pins in the combination in the configuration of DIP. The DIP stands for Dual Inline Package. The frequency range of 8086 microprocessor, that is the 6 to 10 megahertz, it decides the speed of the processor. And coming to the pin diagram of 8086 microprocessor, I already told you the 8086 microprocessor contains the 40 pins. In this 40 pins, this image shows the 40 pins of 8086 microprocessor. Here one side this having the 20 pins and other side that is having the 20 pins. In this particular total 40 pins, some pins are power supply and ground lines, some pins are address lines, some pins are data lines, some pins are control pins here. Here we are not going to talk about this pin diagram. Our focus should be on the architecture and register organization of 8086 microprocessor. In the next topic, we are going to cover the pin diagram of 8086 microprocessor. That means the function of each pin. And coming to the main part of our today's topic, that is the internal functional block diagram. We can also call that is the architecture of 8086 microprocessor. Here we can this image shows the architecture of 8086 microprocessor. If you can see this image, totally this is having the dotted lines. The total functional block diagram that is divided into two main functional units. One is the bus interface unit and another one is the execution unit. The bus interface unit contains some functional blocks, and execution unit contains some functional blocks here. Here coming to the bus interface unit, here we are having some set of registers are available. That is the code segment, stack segment, data segment, extra segment, and instruction pointer. Along with that, there is a address relocator is available to generate the physical address. And another important part is having the 6-byte instruction queue to speed up the process. Then at a time it can able to fetch the 6 instructions from the memory, it can able to put it in the 6-byte instruction queue here. And coming to the execution unit, here that mainly that contains the ALU, arithmetic and logic unit, and this contains some general purpose registers like accumulator, base register, counter register, that is the data register. Along with that, some pointer and index registers are available, stack pointer, base pointer, source index, and destination index. Along with that, this also contains some operands space is available. At the same time, to know the status of the operation, this also contains some flags also available. Yeah, coming to the main operation of this bus interface unit. The bus interface unit, the main function of the bus interface unit is fetching the instruction. Fetching the instruction, and main purpose of the execution unit is decoding and executing. Decoding and executing, these are all the main functions of the execution unit here. Here, as we know that the basic definition of the microprocessor, that means the main, you can define in this way. Microprocessor is a semiconductor IC. Here totally this contains the 40 pins are available. The total CPU functionality that is available on chip. Suppose if you can say 808 microprocessor is having the 40 pins, some other microprocessor may having the other number of pins here. Coming to the basic definition of the microprocessor, total on chip that must contains the CPU functionality. As we know that CPU functionality mainly that is nothing but arithmetic and logic unit, control unit, and a memory unit. These 3 units must be there on top of the internal functional block diagram of that particular IC. If you can see that in this particular total architecture, this is having the arithmetic and logic unit is available. That is the control unit is available. At the same time, memory unit. The memory unit here, the total memory in this particular architecture that is available in the form of registers. Now let's see in detail the operation of the bus interface unit and execution unit. Here, this is the bus interface unit. Now we'll check the main responsibility of the bus interface unit. Mainly the bus interface unit, it provides the 16-bit data bus and a 20-bit address bus. That means D0 to D15 data lines are available to transfer the data, and A0 to A19 20 address lines are available. That is responsible for all external bus operations. That means instruction fetching, instruction queuing, operand fetch and storage, and address relocation, and that is the bus controller. Bus control. That means address relocation nothing but when that is going to fetch the instruction from the memory. First, the microprocessor, 808 microprocessor must generate the 20-bit address. That work done by this address relocator. Coming to the execution unit. That execution unit mainly is responsible for, I already told you, that is the decoding operation. Another one is the execution operation. And another important thing is the execution unit extracts instruction from the top of the queue here. That means it will take the instructions from the memory and it will put in the queue to speed up the process. And another important responsibility of this particular execution unit is it tests the status and control flags. I already told you, to know the status of the operation, we already seen there is a flag register available. And another important part of 808 microprocessor, when that operations are going on, when microprocessor is executing some instructions that will form some instruction cycles. Here now we'll check what are the instruction cycle here, how that instruction cycle that is executed by our 8086 microprocessor with the one small animation PPT. Here now we are going to check the 3-stage pipelining operation. The 3-stage pipelining operation that contains the 3 different operations like fetching operation, decoding operation, and execution operation. Now let's check with one diagram. Here the x-axis here it shows the time period of that particular instruction execution, and the y-axis here it shows the Here it is shows the instructions execution operation here. For example, assuming that here 3 instructions are executing for a one time period. At that time, now we'll check how the microprocessor is executing those 3 instructions. For example, when that is executing the first instruction, first that will fetch the instruction. Next, after fetching that instruction, the instruction will be decoded. That means instruction will be converted into system understandable form. And when the second instruction is getting executed, the first instruction is getting decoding, and the first instruction goes to the fetching process. And when that first instruction goes to the execution process, second instruction goes to the decoding, and third instruction will be in the stage of fetching operation. Here we can check when that second instruction is execution process, the third instruction is decoding, and after that, third instruction will be executed. That means here the instructions are executing one by one parallelly. That means we can able to speed up the internal internal process of our processor. Now, let's check this particular operation of the 8086 microprocessor with the small help of one small assembly code, how the microprocessor is executing that particular addition operation. Here we check the architecture and how the pipelining works here. This is the one small source code is available. Let's check here. First, that is going to get the physical address. It is going to fetch the 2 bytes from the memory. Those 2 bytes will be kept in the 6-byte instruction queue. And that is going to fetch another instruction. And that will keep in the memory. At that time, already one first value stored in the one register. Now the 2 values are stored here. Now, the 2 values are moving into the ALU operations to perform the arithmetic operations. After completion of the operation, the final result will be again that is stored in the general purpose register. That is the finally 0BH that value that is storing the. This is one small video. I hope you can able to understand the internal operation of our 8086 micro, how that is working with the instructions. Now we are going to check along with that our architecture of 8086 microprocessor is also contains some set of registers are there to perform the different types of operations. That means totally I already told you 8086 microprocessor that contains the 14 different registers are available. Those 14 registers here we are using for the different purpose. Some are using for general purpose, some are using for the segmentation, some are using for the indexing purpose, some are using for the pointing purpose, some are using for to know the status and control operation. Now let's check what are the registers available. Here, this is the total register organization of the 8086 microprocessor. Totally in that, if you can able to, that means count here. Totally, we are having the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 registers are available. Again, those 14 registers are classified into 4 different groups. One is the general purpose registers, and another category is status and control registers. And another is the index registers, and next one is the segment register. Here the main general purpose operations, when to store the temporary data, to perform the multiplication operation, to perform while doing the multiplication division operation, to store the resultant, to store the quotient, to store the remainder. Here we are using the sometimes AX and DX register. For counting purpose, mainly we are using the counter register, and here BX we can also call that as the addresses. Sometimes in some special cases, here we are going to store our address in this particular general purpose register. That's what we are calling the BX is the base register, or that is a general purpose register. That means here the AX is accumulator, BX is base register, and CX is count register, and DX is the data register here. Along with that is also contain some segment registers are available. That means CS is code segment, stack segment, data segment, and extra segment. These segment registers here we are using to store the base address or starting address of each and every segment. Totally, we are having the 16 logical segments. You can able to divide the total 1 MB memory space. Each segment contain the size of the segment 64 KB. Each segment that is having the starting address and ending address. To store the starting 16-bit address of the each segment, here we are using that is the CS for the code segment, SS for the stack segment, and DS for the data segment, and ES is for extra segment here. Along with that, to store the offset address, every time in this particular memory operation, here microprocessor is going to two different addresses. One is the offset address, another one is the segment address. You can also call base address. The base address hold by the segment registers. At the same time, the offset address will hold by that is the base pointer, stack pointer, and source index and destination index. These are all of course, that is the instruction pointer. These registers can be hold the data like offset address type of values here. And another important thing is to know the status of our 8088 microprocessor. While performing the arithmetic and logical operation, there is one more important register is available. That register is called flag register. Now we'll check what is that flag register operation. Of course, before we are going to check that that is the flag register, first we will check how that programmer models that looks like for the 8086. Now, coming to the bus interface unit of 8088 microprocessor, totally these set of registers are available. Coming to the execution unit registers, these set of registers are available. You can check all these things in the architecture of 8086 microprocessor. This is the programmer's view. And the last part is the flag register. We can also call sometimes this is a flag register. Mainly the flag register purpose here it is we are using to know the status of the operation while performing the different types of arithmetic and logical operations. The size of the flag register here it is the 16 bits. Now, this is the total 16-bit flag register here. This contains the 16 bits are available. In these 16 bits, only 9 flag bits are defined. Only 9 flag bits are defined. Remaining all flag bits are undefined here. Here, suppose if you can see some the defined flag bits here, I am going to show. Here, the OF that stands for overflow flag. Next, the DF that stands for that is the directional flag. Here IF stands for that is the interrupt enable flag. Next TF is the trap flag, and SF is the sign flag, and ZF is the zero flag, and AF is auxiliary carry flag, and PF is parity flag, and CFE that is the carry flag here. Here for example, totally if you can observe here, totally that I already told you 9 flag bits are defined. In that 9 flag bits, 6 are status flag bits and the remaining 3 are that is the control flag bits here. Here for example, if you can see IF, TF, that one is the IF, TF and another one is the DF. These 3 flag bits are coming to the control flag bits and remaining all flag bits are coming to the that is our status flag bit here. Suppose here whenever we are performing any operation, if the results gets overflowed, what happens here? The overflow flag bit here goes to 1 here. For example, that is the overflow flag bit will be enabled by setting the bit 1. Suppose there is no overflow operation, simply the flag bit goes to 0. Similarly, for example, when that is performing the operation, the result contains the even number of ones, sometimes that may contains the odd number of ones. Suppose that is even number of ones and odd number of ones, this bit goes to the 1 or 0. Suppose sometimes while doing the operation, sometimes the carry may be generated, sometimes the carry may not be generated. At that time, the carry flag bit goes to 1 or 0. That means bit can be set or reset. And another one is the auxiliary carry. There is a difference between carry and auxiliary carry. Suppose if any carry generated from 3rd bit to the 4th bit, that carry we can call that is the auxiliary carry flag bit. Here we can call that is the, suppose while doing the operation, if the result is 0, if result is non-zero, this particular flag bit will be set or reset here. And another important is sign. Sometimes the result may be positive sign, sometimes the result may be negative sign. At that time, this flag bit goes to the 0 or 1. And trap flag bit is the while executing that instruction. We can also call trap as the single step interrupt here. While execution of the each and every interrupt, the trap flag bit goes to the 0 or 1 here. and another important will be IF, that is the interrupt flag bit. Suppose if any interrupt is generated, automatically this flag bit goes to 1. Suppose if there is no interrupt, the interrupt flag bit goes to 0 here. And another important will be direction flag bit. That means while working with the memory, we have suppose if you want to use the upward direction or downward direction, that can be decided by setting this particular direction flag bit here. These are all the some flag bits that are available for our 8086 microprocessor to know the status of the operation. Now, this is the learning outcome. After learning this particular topic, students will be able to use the knowledge of 8086 microprocessor architecture and register organization in the implementation of real-time application. So this is about our architecture of 8086 microprocessor and register organization of 8086 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.